And our final speaker for this session, Carl Hendricks, Senior Engineering Technician with Whatcom County, Washington, is going to talk about multiple heat straightening of bridge. That should be fascinating.
Well, thanks for coming to this today. The bridge that we have is one of our main arterial bridges that carries traffic out to a number of refineries, communities, an island that we have a ferry that we oversee too. Bridge number 512, it's a steel truss bridge. The bridge, it gets like right now I think it's like 15,000 ADT nowadays. I don't have the current one anymore like I used to. Looking out towards the mountains there, Mount Baker in the background there, if anyone's familiar with Washington. We're located up in the northwest portion of the state. I'm really near the Canadian border. It was built in 1957, truss-through bridge. The main max span is 240 feet. It's got a width of 32 feet on out-to-out, basically, and a 26 curved curb. Vertical clearance, when you measure it at the curb line, is 15.3, and we post it for 15 feet. But when you measure the center, and it's a curved portal, the center portion, it's at 17 feet. It's a number to remember because when you see what hit it at one point, you'll understand that. Again, like I said, it goes to refineries, an aluminum plant, it goes to an Indian reservation. And of course, Indian reservations have casinos, which that is a huge deal on this one. They actually had a special going. It was Broken Bridge Bucks is what they called it. Trying to encourage people to go out. And of course, this had to happen 3 times that we had to deal with this. First one was in 2003, kind of a typical accident. It was damaged on the 23rd, a Sunday. Local contractor, of course, moving equipment, not during a normal work day. Kind of tells you that they're trying to do something that wasn't probably supposed to be being done. Pretty much the excavator, when they loaded it, the person that loaded it did not have the experience, so when he loaded the machine onto the trailer, he did not curl the bucket all the way underneath. He basically sat the bucket straight down, so your boom and stick were up pretty high on this thing. So he was traveling westbound. He hit the west portal first, skipped the next cross member, and then proceeded to hit every single cross member across the bridge. A person was driving behind him, called 911. We contracted at the time, Washington State did all our high-cost bridge inspections. So they came up and did an inspection for us on the damage. Again, it was a local contractor, and it wasn't a small one, which was really a surprise. It was one of our main contractors in the area. So he kind of ate mud on this one. It was a blessing for us in ways because the local contractor hired structural engineer for us for the project because they were the ones going to be paying for this damage. The structural engineer ended up doing work for us for a number of years afterwards. He was a really good engineer, very good field engineer, so we ended up using him on a lot of projects. So that's why it was a blessing to us. That was the blessing. Plans and specs were done in 2 weeks for this project, and then the contractor contacted a local company, which down in Snohomish County, which is 2 counties south of me, is a company that does this work. They do this work all around the world, and it's really an art form. There's engineering to it, but the guys doing the work, they understand heat like you wouldn't believe. They understand how steel heats and how it functions when it's heated. Kind of the damage you can kind of see on the portal there where it's been ripped, right next to a gusset plate there on a connection point. And the next picture over is you can see all the orange paint. Now I know all our new painting coating systems nowadays, they're different colors, but they're not real different in colors. I recommend if you can, get the brightest primer you can because it shows every bit of damage when you have an accident like this. You can see the orange throughout this whole thing. Orange paint, typically you'll have lead in it. Well, this bridge did not. It's a good thing. We got lucky that it didn't have lead in this orange paint. You can see other members that are bent on this thing. Engineering cost was around $40,000. And construction was $125 is what we estimated for this. Construction and repair started on the 5th, and we completed on the 19th. So we did all those repairs. The bridge was open to 1-lane traffic on this particular repair that we did. Final cost for the engineering came to only $32,000, and the final construction cost was $115,000, basically $115,800. So it's a good way to go when you start having to replace steel and starting to add jacks and all your safety stuff and everything else, your costs go way up. By doing this type of repair, you get to leave everything pretty much in place, which makes a big difference. Our next one was in 2006, so 3 years later. This one happened, of course, on a weekday, which was good. I had just gotten home and got the call that we had something stuck in our bridge. Basically, this load that was stuck, there was 13 identical loads like this going to be going over this bridge, going out to one of the refineries. We permitted this load. They actually gave us an application. We permitted the load, gave them restrictions, told them to drive down the center lane of the bridge, told them to close the bridge down on both ends when they went across. So that was part of our permit conditions on this. The bridge, they'd taken 6 loads across, so everything's been good until the 7th load. 7th load started across, and the truck driver claims that a car was coming at him from the other direction, so he stayed to the side. And by staying to the side, which is on the north side of the bridge, the load struck the first portal, or the east portal, and then started grabbing, as you'll see in these pictures, grabbing the cross bracing. The load had a full cage around it for taking the vessels that was going up. Engineering cost for this one was $42,600 we estimated, and $139,950 to do the construction. Construction started on 8/24, work we finished on 10/1. And when you see the damage on this one, you'll be, I think, a little surprised how fast we got it all done. The bridge was closed to all traffic on this particular repair. We couldn't have any other traffic on this bridge at this time. Engineering cost came to $47,000 for this one to be completed, and then $132,000, almost $133,000 to do the construction. So there you can see one of the cross members that are ripped completely off, your vertical. It did it to a few of them, not just one. Couldn't have been that easy. As you can see, there's more damage of those. Those verticals were out of plumb. The first one was out by 2 feet out of plumb. The other one was out over 1.5 feet. Well, by these being out of plumb, you can imagine the north side cord on this thing dropped. It dropped over 6 inches on this bridge. Deck and everything it was in good shape. We didn't see any drop in that. As you can see how this looks as it's been ripped off. The strap you see in there, we put it in there when we were trying to remove the load. We didn't want it pulling on it any more than it already was. Again, I'm just trying to show some of the pictures of, the damage on the out of plumb and everything on this thing. Some just localized issues throughout the bridge. Railing gets damaged when something like this happens. It's not just your verticals and your cross bracing. You start looking at a bridge, it's everywhere all of a sudden when you have these kind of issues. And again, why I said orange paint is great. You can just walk the bridge and start seeing all the issues right away. And here on the lower left corner, that's just looking down the cord. You can't tell that it's lower, but it was 6 inches lower. Here we're starting the repairs. So with heat straightening, it's all done with heat. I don't want to get in real depth detail on it because there's a lot to it, but basically you're heating the steel to a certain point, and you don't want to go over that point, or you don't want to be under that point. And when you see all these braces and chains and stuff, they're not pulling the steel back into place. That's just holding it in place. None of those things are piano wire tight or nothing. By using the heat process on the steel, you can actually make the steel go back to its original shape. You just need to know where to do it, how long to do it, and what patterns to do it. And that's why it's such an art form. It's not something that you can just pick up and grab a maintenance crew and just go start doing something like this and learn about it. It takes time and a lot of practice to get there. Most equipment used on this was, of course, a Manlift. This company customized this truck. So that truck carries everything they need in it. The top is a platform, so they do a lot of work right off the top of the truck. So all your gases that you're using for heating and all your tools are inside it. So it makes the process pretty small, pretty clean. Here you're starting to see some of the repairs, what it looks like afterwards. You can see that the verticals are straight up and down again. You can see the cross bracing still is back into its place. That's no new steel. That's all the original steel that was on the bridge. So it's all been heated slowly and back, and it's just a process. As an inspector, when you're on the site, you just want to sleep the whole time. The process is so slow. It seems slow, Fortunately, I've been on this repair 3 times now, so I've seen this with the same company 3 times. And you can see some of the tolerances we got back. I've got up there. The verticals were within 1/8 of an inch plumb again. You've got your cross bracings were all within 1/8 to 1/4 inch going across. And then the top core we got into 1/4 inch. And that's doing no jacking. That's just heating the steel and letting it cool correctly. You don't use water, you don't use anything. It's all natural. You let it cool. Guys that are newer in the business that have been working with the guys that have been in a long time, they use a crayon to check the heat. It gives you a temperature reading based on the color. You'll find the old guys, they don't like to use the crayon. I tried testing them. They knew what they were doing. Made me look like a fool. The next one, 2012. As you can see, it seems like every 3 years I'm out on this bridge, or it's multiplying by a few years, but it's consistent. This one again was another excavator going westbound. It happened on the 24th of the month at 9:30 a.m. So it was in the morning. Local contractor moving equipment. No one knew. He loaded the excavator exactly like the other guy did. With him loading it the way he did, one of the beauties of this one, he started so far away from the bridge that we followed from where he started to where he got to the bridge. And if he would have made it through the bridge, he would have hit the rail crossings next. And after that, all the damage would have stopped, because that's where he was trying to get to. So he took out power lines, he took out signs, he took out all kinds of things with this. And he just kept driving on this one, which was amazing. He got called in by a person driving. As our sheriff showed up, this fellow had the machine back on the trailer. He was trying to leave. Lucky for us, when he went through, he had a chain binder on the bucket and it came off. So it allowed the whole excavator to swing sideways, catch the bucket on the railing, help pull the machine off, and put it in the middle of the road. So it gave us time. So he had to get it started again and get it up, right, and on a trailer. So it tells you how long it took our sheriffs to get there even. Again, damage on the bridge was significant enough. We had to do a bunch of work on this one. Plans again, 2 weeks. I mean, it's almost exactly the same repair as we had the very first time this happened. So it went relatively easy. Contracted this company in Snohomish County again. Name of the company, I'll just say, it's Flame On Construction, Flame On. Fortunate for Whatcom County, where they're located, each time these accidents happen, they happen to be home. They're a small crew, and they travel the world doing this work. And each time they happen to be home, it was lucky each time for us. Just kind of showing on the guardrail, there's a little damage there where the machine started coming off there, showing some of the repair works in there. Engineering on this one, we figured 30, and the cost was a little higher this time. And the reason why is we knew we were going to have to replace one place, some steel on one place. As you can see, as soon as you start adding steel in it, the cost goes up quite a bit more all of a sudden. The only reason why we had to add new steel is because they literally ripped the whole portal apart. So can't fix that. Construction started on the 3rd and we completed on the 21st. So you can see it's pretty quick work for the most part. And these aren't like working all night long. This is just a 10-hour day, 5 days a week working. We didn't work weekends on this. The engineering cost came out to $28,600, and the final construction costs came out to $223,750. So each time we've done, our estimates were really good, so it was a good thing. Of course, every one of these repairs was paid by insurance companies. It didn't cost the county anything 3 times. So that was the good thing. And just showing the guardrail on the end of the bridge that was damaged from the machine laying there on its side. This is the portal where we had to replace the actual steel. They had to cut it out, fabricate new pieces, fabricate it all on site, trying to get the curvature. Believe it or not, we use heat straightening to get the curve in the steel eventually, so it actually all looks like original steel just by using heat straightening. We actually made the steel curved instead of making it straight again. Again, Manlifts. This time again, we closed the whole bridge down on this one. You can see there your cross members bent the other direction. Now this one's been bent this way twice and once the other way. This is one of the cross members that was completely ripped off. So this has been done multiple times. Again, same truck, same crew, same guys working. It's real hard to see, but a lot of that when they're doing the heat straightening, it's like I said in patterns. A lot of times you'll see a V shaped in the heating. That's doing the process of pulling the steel or pushing the steel, whatever they need to do. It's much better to be on site and actually see what it actually looks like. Conclusion on this, Whatcom County has found this is a good way to go. It's been good success for us on this whole process. We do not have we have one other steel truss bridge and it's been hit, but it's up almost at 19 feet at your vertical or your portal. And that was just due to a logging load, but it was fixed relatively easy. So we don't have a lot of bridges that have this issue on, which is a good thing. Low cost compared to replacement or replacing all steel, because if you think how you had to replace verticals, cross members, if you had to have them all built, fabricated, you can see the cost going way, way up really fast, and time. And then all the jacking you'd have to do, it would take a long time to get some of this work done. That's why we chose to continue using the heat straightening. As you can see, I'm saying, well, the way things have been going on this thing over the years, for the fourth time, it should be in 2024, I should be out there again at the rate it was going. It's actually been hit again since then, but it was just on the east portal. Someone hit it with something, we couldn't figure out what it was. It didn't do enough damage that we need to do anything quite yet on it, which is a good thing. The bridge has been repainted since all this work. Basically, just a little background real quick, heat straightening process was really found out through welders. Welders were the ones that kind of figured out how to bend the steel, move steel, make it change shape. A fellow named Josh Holt came up with some specs, some kind of form of specs for this thing in 1938. So it's been around a long time. The process has been around a long time. 1980, most states were still not using this process. So it's actually kind of young when you think about where we are with this work. It's used a lot more nowadays. All your damage is categorized into different levels when you're doing the heat straightening. So there is some information on that. And there's a good technical report that was done by FHWA in August of 2008, going over the whole process of heat straightening. And if anyone wants that number, I can get it to you if you're curious. But it's a good report. It goes over it. Just on a side note, we have a ferry landing. I don't have pictures of it. I wish I could have got them in. I was going to, but the last 2 weeks we were in major flood damage up in Whatcom County. We got hit like Abbotsford, BC. Before I left and came here, my last week I had over 70 hours of work in a week. We had lost one bridge in the flood, and we had a lot of damage across the county. But we have a ferry landing. It has fracture critical members. It's got what's called live load hangers. Washington State Ferry System has a lot of these live load hangers too. And they had a lot of them bent over the years, and they've put alarms and done some new designs so the ferry apron picks up, it doesn't bend them as fast. But we still have the old style. We tend to bend those things, our crew tends to bend those things every few years. And we've been heat straightening those things, and we were kind of curious how many times you could actually heat straighten it. Well, lucky for us, Washington State had a number of ferries. They actually did a study. They actually did a study and heat straightened a live load hanger over 100 times. And it's still as strong as it was from the beginning. They had no issues with it since. They've done a ton of testing on it. So makes us feel pretty good. So we thought, again, like I said, it's an artwork. We decided we took an old live load hanger we had, and we thought we'd try and practice and see if we could do this work. It didn't go well. It never went back to its original shape. We could never make it do that, and we ended up heating it too much and then deforming the steel. Then it's no good. So you're done. Once you deform the steel with the heat, you're done with that piece of steel. You cannot try to re-straighten it at that point. You've changed its strength and everything on the steel. So, like I said, it is definitely an art form, and if you guys have steel truss bridges and then you just got a few members that are bent and stuff like that, I think it's a great way to go to fix them. It's cheap and it's fast, and you don't have to worry about having issues with strength on it. It's been proven that you can do it quite a few times. Any questions?
Were there any issues with the lower cord connections due to the impact to those sway braces?
Not really. Basically, we had a couple little tiny tears where we had to do some field welding on, but then, of course, they were inspected and UT'd and everything else afterwards. We didn't replace any spot where rivets were bad. All were replaced with bolts. In Washington State, we don't encourage going back to rivets. We always go to bolts if you're replacing a connection like that. All the plates, when we pulled the bolts out, we looked to see if there's any elongations in the holes, anything weird, and we didn't find any, so that was a good thing. So we were able to continue using the same gusset plates and connection points.
You mentioned the 6-inch deflection of the upper cord or one of the cords. Did that come back out when you heat and straightened it? You
Yep,
mentioned the
we got it
corners.
within a 1/4 inch of its original height, which was amazing. I didn't think it'd happen. Flame On was convinced they could do it, and I'm glad I didn't bet them, because actually the state DOT, they have a underbridge a U-bit truck that we don't have. So they actually came out and did the measurements with me originally, and then when they came back out to measure it again, he was swearing he was on a different bridge because he didn't think we'd get it back within that kind of tolerance.
Since the bridge has been hit many times, did anyone consider having like overhide protection before the bridge so it kind of stopped the truck?
Oh yes, that discussion's been made many times. When it's on a route like this with refineries and an aluminum processing plant and things like that, trying to convince them that this is a good option doesn't go real well. I don't know why. It would definitely keep things from happening, but it's been talked about many times. We've looked at putting an I-beam across. We've looked at putting sensors that would trigger lights, at the beginning of the bridge. Like if you trigger that height, it would start flashing at you and everything else. We've looked at a lot of different things, and the costs of those have been so much higher than what it's cost us to repair the bridge each time, so no one's been pushed to do anything with it. So the one thing I failed to kind of talk about real quick is that load. What was interesting about that load, and I think I had it in the notes, but the 6 loads that went over, made it through with no trouble. This one, even if it went down the center of the bridge, was going to hit the bridge. Unfortunately, when they loaded this particular load, they used different dunnage on this load. So the truck driver and no one measured it. So they had no idea that it was actually 6 inches taller than all the other loads. So it would have hit the bridge, because with the curvature of the portal, it was still going to catch it, even if it went down the center at that point. Dunnage is pretty important. If you got multiple loads of the same thing, is to make sure we actually now put notes in our permit saying use same dunnage, because it changes your load, and most drivers don't check that. So
I'd like to thank Carl. Very, very good presentation.
thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.